Hello, welcome to this video of the classics. Today I'm going to talk about number 7. So we have um, g of x of t, a function that is called the fonction génératrice in French. I don't know how it's called in English though. It's equal to the experience of t to the power x, with x being null, random real variable. So that's the definition of the um, the fonction génératrice. So it's equal to the sum between 0 and plus infinity of the p equals to p, the probability. Oh, also it's double p. Thank you. That x is equal to n times t to the power n. So we'll take each of the integers value and take its probability, then we'll multiply it by t to the power n. So the goal will be to prove this formula here, that the experience of x is equal to the to g prime of x in 1, and then that the variance of x actually is equal to j prime j of x prime prime, so the derivative of the derivative, in 1 plus g of x prime of applied in 1 minus g prime of x in 1 squared. Okay, so the 7 7 7 7 7 7 7 7 7 7. So we've got our I take the derivative of the function j. So this does not derivate because it's independent of t. So we get the derivative of t to the power n, and that is equal to n times the constant times t to the power to 1 power less. So t to the power n becomes t to the power n minus 1. So this is the derivative. We apply this in 1. So we get this, but this is actually the definition of the experience. So we've proved the first formula that we only need to. So by definition, the variance is equal to the experience of x minus the experience of x squared. So basically, what this means is that you set another random real random value that is centered around its experience. So the probability will not be at some experience e of x. It will be centered at 0. So what this does is that it centers the experience. So the variance is this, and we'll develop this. So x squared becomes this 2. So we got 2x minus e of x, so we get this, plus e of x times e of x, because it's applied in this. So we continue. So we have this random value that we can extract by linear. Oh shit, there is a storm, it surprised me. Okay, so there are actually really spooky thunder out there. Okay, so we have the value, the variable x squared, and by linearity we can extract it. So we have the experience of x squared. Then we have the experience of this. So it's become twice the experience of this, and this is a constant, so we can factorize it with the 2. So we've got 2 times exponential, the experience that comes from applying e to this and to the x that is here, and then the e of x goes here, plus exponential experience of a constant that is here. Oops. Experience of a constant that is here is just that constant, so this doesn't move. So we get this. Then we have this that we can factorize, because this is actually experience squared of x. So we have -2, and here we have 1. So -2 plus 1 is equal -1. So we get this. This is the formula known as Koenig-Huygens, the mathematical version, because there is one for physics. So the variance is equals to, wait, what? No, this is actually false. No, that's g of x. No, double g of x applied. Okay. So the thing is that I'm going to derivate it twice. No, actually, I'm going to keep that. So we have the variance that is equal to the experience in x squared, but we already have the expression of e of x. So by the theorem of transfer, we can apply it here. So the n will transform in n squared. So we have our n squared. And then we know that the g will be applied in 1, so we have 1 to the power n. Okay, so we have this formula here, minus this part, because we have e of x squared, and e of x, we found it earlier, it's this, so it's this, so it's this. So we're not going to touch that. So we have this, but we can split this as being n minus 1 times this thingy here, plus the sum of n, because n minus 1 plus n is equal to n squared. So we just split the sum, and we get this formula that is the n. And that's it. Thanks for watching. If you have any question, feel free to ask them in the comments, and I'll be glad to answer them, and bye.